Welcome again. Today we're looking at conceptual database modeling. Basically, this is the entity modeling, and we've divided entity modeling into two parts. So we are going to have part one and we're going to have a part two. Now, when you're talking of an entity, is basically you need to be able to understand it from the perspective of where we're referring to an entity as anything that we can be able to collect information about. So an entity model is where now we begin to create different relationships between these different entities that we want to use in maybe the definition of how we define our system and how we can be able to store data in our system, and therefore it becomes a representation of data that will be used in our system. And it will show how data will be logically grouped, how we can be able to separate one type of data from the other data and still be in a position to maintain relationship between these different data as we construct our system based on business requirements. Now, there are a few key terms that we need to note. When we're talking of an entity, as I've said, is anything that we can be able to collect information about, and an entity is an object that exists, and that is why it's anything that you can collect information about, and you should be able to distinguish it from other objects. And when we're talking of the entity set, we are looking at it from the perspective where we have a grouping of some sort. Example, we have a set of all people, companies, trees, holidays. Instead of looking at it from a singular perspective, we are looking at it from the plural perspective. So a domain will basically be a set of permanent values that, will be a set of values that will be permitted for a particular attribute. Now, attributes, we use attributes to explain what an entity is all about. That is, to be able to give a good description of an entity. Like example, if you're talking of a student can have a registration number, can have a first name, last name, and so on. So that's basically what we refer to as an attribute. So we have single valued and multi-valued attribute. Example of multi-valued attribute would be a phone number. A phone number can have an area code, can have maybe the number that would represent the company that you are signed up for telephone communication with, and then we can have the actual number that we can dial to be able to reach you, especially if we are calling from another country or we are calling from another service provider. So again, we have the derived attributes, and these are attributes that can be computed from other values of attributes that are already in existence that do exist in the system. Example, when we are doing registration, maybe for students, or maybe you are registering to be part of a particular social media network, and you're sometimes asked to provide your date of birth and all that. So once the system has the date of birth, it can be able to compute the age of that particular person who's doing the registration. Primary key will be any key that we can use it to uniquely be able to distinguish from one record to another. And that candidate key would be any key, or rather any attribute that can also be uniquely used to identify records in a table. However, we are not using it for purpose of identification such as a primary key, but it can be, and that is why it is a candidate key. It fits all the properties that you would require for a unique identifier of a record, but we're not using it for purpose of uniquely identifying that particular record. Now, relationships are basically meaningful association, and those are very important, especially in relational database systems where we want to have a relationship from one table to another table. Then we talk of basically the cardinality, which is the degree of relationship. In most cases, when you're looking at cardinality, we're looking at it from the perspective of one to many, many to many, many to one, one to one. That's what we're referring to as cardinality. Now, the entity relationship diagrams themselves, we denote them as ERD, fall under now the entity model. When you're talking of entity model, you're talking of that and the associated documentation that will be required for us to be able to fully come up with a good schema, database schema. So logical groupings of data relevant to the application under investigation. So that's basically what it's all about. You are trying to introduce logic into the association from one table to another table, and unidentifiable objects, concepts, or activity belongings to the application about which descriptive data is stored. So by looking at that kind of ERD diagrams, then we begin to have a deeper understanding of the kind of database developer is trying to design. Now we said attributes basically are what we have to use to basically be in a position to describe an entity effectively. Like if it is a student would have a registration number, first name, and so on. Those would be the attributes. So we have some that are key attributes, and we have others that are not key attributes, hence they are non-key attributes. So attribute domain itself would set a value that may be assigned to a particular attribute. It can, example, if it is a date of birth, can only maybe take a format of a date. If it is the name of a student, can only take the format of alphabets, and so on. So we have simple attributes, and then we have composite attributes. If you're looking at it from simple attribute, can only contain maybe one atomic value. If you're looking at it from the perspective of composite attributes, then we can have not more than one attribute forming what you'd like to be able to fetch from the system as a description of an entity being represented as from a single perspective. Like if it is name, we know very well that name as first name and last name. So if we are looking at it from a single perspective, it's just name. If you're looking at it from the composite attribute perspective, is first name, last name, or it can be first name, surname, whatever concepts that you're going to use to be able to distinguish between 2 or 3 different names. There are people who have 3 names, not just one. It could be first name, middle name, and then maybe surname or last name. So those are basically what we refer to as the single valued or even multi-valued. We have derived attributes, and derived attributes, we've said that they are attributes that we do not need to store in the database. They are computed from other attributes, like age of a student can be computed from date of birth. So there is no need for us to be able to store that. Now, a relationship, which we say that it's very important for us to be able to introduce it in a database system. And for us to introduce it in a database system, then we need relations. Relations are more like tables that we can have in a database. Then what is the relationship between one table to another table? Example, if you have a student table that stores information about students, that is their registration number, first name, last name, the course they are taking, and so on. We can have another table, fee table, that can store information about payment of tuition fee. If a degree program would cost about maybe, let's say for sake of argument, it would cost maybe 30,000 shillings per semester, then what are we talking about? We are talking of what is the relationship between the student table and this other table we are calling a fee table. So that's how now we begin to build meaningful relationships between different tables or different relations. So degree of relationship would be the number of participating entities in that relationship. Now, given entity A and entity B, looking at it, we can have a one-to-one relationship. That is, this entity A can only participate once in entity B, and entity B can only participate once in entity A. And that is a one-to-one kind of relationship or association. A one-to-many a relationship, and remember, these are what we are referring to as cardinality. When you're talking of cardinality, that's the kind of degree of relationship that we are looking at. So we can have, for any A, there may be many number of B. For any B, there may be only one member of A associated with it, and therefore that would form what we refer to as one-to-many relationship. Like here, a customer can make many orders We can have one customer who can make many different kind of orders. But we're saying, if you look at it from this perspective of entity A, entity B, here you can see we have a profit here. Let me see if I can get the pen to draw it properly. Here we have in a profit here. This we refer to it as a profit. So this is one to many. Yeah, many, one to many. Entity A can participate many times. So one to many relationship. That's how we'll be able to show it in entity modeling diagram. Now, a many-to-many relationship is where all these entities, let me get the pen again. We have, we're saying we have for A, it's not clear. I'm trying to make them look a bit more clear. Yeah, that's the profit we're talking about on both ends. So this represents many-to-many kind of relationship. So for any A, there may be many members of B, and for any B, there may be many members of A associated with it. Example, we can have many customers for products, many products for the customer. So that's a many-to-many relationship. However, you must remember that many-to-many relationships, we need to be able to find a way for us to be able to decompose that kind of relationship. So we have one-to-one, we have one-to-many, and then we have the many-to-many. So many-to-many must always be decomposed. We do not encourage that when we are designing database systems. Now, constructing an entity model. Step number one will be to develop an initial entity. That is, come up with the entities. Figure out what kind of information that you want to collect. You want to collect information about what? So identify the object about which the system currently holds. These may be done using interviews, notes, document reviews, and observation. If you're called upon to develop a system, that system is going to store data. But the question that you need now ask yourself is, what kind of data will it hold? It's data about what? Hence, we're saying you need to be able to identify those entities. So then figure out the initial relationship. That's why we're saying successful identification of relationship between entities would demand constant reference to the business requirements. See, before you can decide to develop any kind of system, you must have done, and this is usually done by system analyst. You'll need to go and collect the user requirements or system user requirements, then come up with a system requirement and all that. So when it's coming up with those system requirements, they're basically now the business requirements. It needs also to be able to look at the environment, look at what is available, and then if it is a database, now begin to build the initial, come up with the, since you already have the entities, then begin to identify the attributes of these particular entities, then again begin to see if there can be any relationship between one entity and another entity. There is also validation, or that is, you need to validate against the current system. Look at the what current system they already have in place. Then see if there is anything that you can borrow from the current system that can be applicable as you're coming up with your own ERD diagrams. So that's how we are able to validate, make sure we are still following maybe the culture of operations, how they operate things, how they store their data and all that, with that's the little improvements that may be required through the user requirements. That's why we say ERD is logical and so does not show physical aspects of the current system. So you need to be able to look currently what is there. You'll be able to get more information on how you can be able to design it much more better. Then extend the entity model to cover the new requirements that you've been able to collect. That is what was there, and then there is the new requirements. Then how do you fit them all together? So EM is extended to cover the new or the entities needed to fulfill the new requirements, because the new requirements may dictate that now there is an introduction of another entity. Now, example, we can have a system for university system where we have a student module, we have administration module, we have a fee module, but now we want to introduce a new entity, and this could be hostels. So if we're going to collect information about hostels, then how do we model the whole thing to be able to extend from the original now to cover the new requirements for hostel? Rationalize the structure. A review of ERD is required to ensure that it is the minimum logical model required to support the system. Don't leave anything out that may be important for the for effective performance of the system at the end. So you must make sure that you're going to cover every entity that is required for full functionality of that particular system. And it is important to also again keep on showing how they link from one entity to another. Then you can do a revalidation with the users, and then users can be able to agree if this fits with the requirements that you've been able to collect. Now we can have other relationships where we have a recursive relationship where we have one example. We can have employee who's married to an employee, so they are both employees. So how you represent that now can be based on the role played by one to the other. Now we can have one employee who manages other employees. See, you look at it from the perspective of he's a manager, but at the end of the day he's also an employee. So how do you draw that kind of relationship? You can see we have some kind of recursivity of some sort. When one employee is married to another employee, they are both still employees. So as you draw that, there is a recursive kind of line that you have to draw. Now again, we can have optional or mandatory relationship. In our optional relationship, an entity occurrence in one entity would need not have any occurrence because it's optional. You choose whether to have it or not to have it, but there are those that are mandatory, and mandatory must be represented in that kind of relationship. Cardinality constraints. Remember, cardinality, we are talking of one to many, many to one, and many to many. So, and that is the degree of relationship, would describe the maximum number of possible relationship for each participating entity. Sometimes we have constraints that are set, like when you say a professor can only teach 3 units per semester. So you've set a constraint, though it is one to many, that is many units can be taught by a professor, but there is a constraint on how many. There are 3. So that's basically what we are talking about here. Like here we have a lecturer teaches at most 3 classes per semester, and each class has at most 1 lecturer. So you are setting the constraints. A student is limited to 6 classes per semester, and a class size is limited to 35. So those are the constraints that you are already beginning to set. So if we are going to have that kind of representation in ERD as shown here, there's a correction here. This is supposed to be 35. So these are 35, and we are saying we can have a minimum. There can be we can have a minimum of, let's say, based on this drawing, we can have a minimum of 5 students. So it is 5 to 35 for a class. So we can have that kind of representation. For a student, we can take 1 to 6 classes. One lecturer can have 3 classes. So we need to push this somewhere here, closer. Okay. So we have participation, constraint, existence, and dependent. Determines whether the existence of an entity would depend on it being related to another entity through the relationship. There's what cannot exist before the other is in existence. Like we cannot talk of course units without having the course program itself. Just like we have an example where we're saying we have course that will generate classes. So it's from the course units that we can get classes. So again, go back to modeling, and we're saying database can be modeled as collection of entities and relationship among these entities. And that's basically what at the end of it all we give us what referred to as a schema. And again, we said an entity is any object that exists and it can be distinguished from other objects. Hence, it is anything we can collect data about. We have examples such as specific person, company, event, we have plans, and then we also have entities, also have attributes, because this word tells us more about this entity. This word helps us to be able to distinguish this entity from other entities like name, addresses, if it is a student registration number or ID number, whichever you choose to call it. So an entity set is a set of entities that have the same type groupings. Yeah, I think we covered this one. Now here we have a representation where we are looking at loan against customer. So a customer can go to a bank and request a loan. A loan can be associated to a customer. So here's an example of that kind of relationship. We're looking at it from the perspective of tables. So these are two tables. One is for customer and the other one is for loan. So a relationship, we can create a relationship between those two, where we're saying a relationship is an association among several entities. Example, Hayes, who deposits in a particular account. So here we are. We're saying now we have Hayes. Let me get the pen. We have Hayes here, who is depositing to that account. So the relationship that has been created here is deposits. He has borrowed an amount of money from the bank, so he has a loan. And also we can be in a position to associate that loan with a particular customer. So we need to find a way to uniquely be able to associate this table with this other table. What would uniquely be able to associate that is if we can find the primary key for this particular table. Maybe this would be the primary key. Then we can have a loan, and a loan can have its own primary key. But we can decide to associate this by introducing this to this particular table here. There's maybe another additional column there, so that when you are looking for Jackson, you're looking for this number in this particular table, then you can be able to identify the amount of money Jackson has borrowed, and then that loan can maybe have now a unique number that can be associated with it. Now, relationship set, again, attributes can also be property of relationship sets. Now, if you create a relationship, like when you say it is to deposit, it is to withdraw, right? You are trying to create a relationship between customer and maybe a particular bank account, so they can be related. When you can create a relationship set such as deposit, such as withdraw. But this deposit, this withdraw, you can also give it its own attributes, and that's how now relationship sets begin to have attributes. Now, degree of relationship, we talked about that, and remember this is basically the cardinality. However, we say in relationship sets that involve two entity sets are binary, and that is normal. Generally, most relationship sets in the database are binary, and that's why I'm saying that is normal. So we have relationship sets that may involve more than two, and these are ternary relationships. So, example, suppose employee of a bank may have a job that is a responsibilities at multiple bank branches. Same bank, but it's having different branches. So with different jobs at different banks, then there is a ternary relationship. These are ternary relationship of more than two. Yeah, we're calling it ternary relationship. So you can use that concept of relationship set to be able to to show that in a ERD diagram. Remember, attributes basically describe more about a particular entity. Like we have customer here. Customer is an entity. Now, customer is an entity here, and also bank is an entity. But then we have, these are the attributes now that tell us more about the customer. These are the attributes: customer street, customer city. When it comes to loan, we have a loan number and there is an amount. So generally, at the end of it all, we'll try to find what is the relationship between customer and the loan. That's what we are looking for. So domain set of permitted values that you can enter in a particular attribute. You can only enter maybe integer values, you can only enter alphanumerics and so on. So we have types such as symbol, composite, I think these we looked at, single valued, multi-valued attributes, and then we have derived attributes such as given the date, we can be able to derive an age. Now, composite attribute can best be looked at using this kind of graphic representation. We have name can have first name, middle name, and then last name. Address can have street, city, state, postal code, and even the street itself can also can be composite in nature by having street number, street name, and then the apartment number. Hence, now we get into cardinality, and remember we said that cardinality was the degree of relationship that we can have one to many, that is one to one, one to many to one, and many to many. And we said many to many relationship, we need to be able to dissolve it. So the first one that you can see here, the relationship between A and B. A and B, basically that is one to one, and then B here we have been one to many. That is, like if you look at A2, looking at A2 here, and even A1, the kind of relationship that we are having, it's one to many, because we can have many that such as B1 and B2 associated with A1. Here we have B3, B4 associated with A2, and we can also have representation of one to one. So generally, if we look at it, that is all one to one, meaning there is a possibility for A3 to also be associated with more than what we are seeing here. We have many to one is when you look at it now from the other angle, where we have B associated with many of A, and then many to many we have many of A associated with many of B. So that's the cardinality that we're looking at. Now next we have representing specialization as schemas. We have two different methods. Form a schema for each entity set. Now if we come up with student as an entity, customer as an entity, then clearly show these particular attributes for each and every one of them. So if specialization is total, the scheme for the generalized entity set person not required to store that particular information, and therefore we can be able to define it as a view, a relation containing union of specialization, and therefore when we use that particular entity, then we can get a view of many others. So, but explicit schemes may still be needed for foreign key constraints. And remember we said that foreign key is when you have an attribute that is appearing in a particular entity, but it's in that particular entity it's appearing is not a primary key, but it is a primary key in another entity, or rather in another relation. It is in one table, but it is not a primary key, but in another table in the same database it is a primary key. An example would be basically where you have what we can have a table for students. You can have registration number, first name, last name, and then you can have course code just to indicate the course which the student is taking. But in that particular table, registration number is the primary key. But if you go to the course table, course code is the primary key. So therefore, the course code in the student table will be a foreign key. So here we have a drawback where we have street and city may be stored redundantly for people who are both customers and employees. So when we have those kind of relationships, then we introduce redundancy. And remember we said for database system, we are trying as much as we can to reduce the number of redundancies and duplication. So if we have dependencies, if the existence of an entity X depends on another entity for its existence, then we have existence dependency. So that's basically what we refer to as existence dependent. Now, Y is dominant entity. In example below where we have the loan, and X is subordinate entity where we have payment, because we can never have payment if the loan is not there in the first place. So if a loan entity is deleted, then all the associated payment entities must also be deleted.